Okay, let's do some more practicing solving equations that contain fractions. Since fractions seem to be the biggest tripping point for students, and learning how to work efficiently and effectively with questions that involve fractions is really vital to being successful in any kind of algebra or calculus, pre-calculus, any type of classes that deal with algebraic expressions or equations. They're always going to have fractions, so you have to be comfortable working with fractions. Now, like I've said in other videos, books and teachers will talk to you about finding the least common denominator or the least common multiple of your denominators, and that is by far absolutely correct, and it is absolutely the most efficient way to get your answer as far as the number of steps is concerned, but it is also, in my opinion, the most dangerous way to get the answer because it opens you up to the largest possible number of mistakes. Finding the least common denominator is where students make mistakes. It's where your brain starts to pause and you feel like you don't know what you're supposed to do. It's the most confusing part, and it's the part where you can make the most number of mistakes. So instead, my suggestion is instead of finding the least common denominator, just find any old denominator you want. And the simplest, easiest denominator is just the product of all of the denominators. So whenever you have fractions, get rid of those fractions by just picking the largest, most complicated denominator and multiply everything through by that. The reason why I say largest, most complicated is when you're dealing with numbers, you're just picking the largest number. So in this case, we'd multiply everything by 6. But we're going to see some examples later where the denominators are going to have variables in them. And if there are variables in them, pick the one that's the most complicated, multiply it by that, and oftentimes it will kill off multiple fractions. So for instance, let's start with numbers, and you'll see if we pick the largest one, so now we're going to multiply everything by 6, which means we're going to multiply the left side by 6, right, and the right side by 6. And if you multiply the left side by 6, that means you got to multiply this one by 6, and this one by 6, right, and this one by 6. When you multiply 7/6 by 6, you just get 7. But look what happens here. 6 times 2 is 12. 12 divided by 3 is 4. We killed off that fraction as well. Okay, now what about this? How about 6 and 4? Does that reduce? Yes. If you don't see that, that's fine. Don't worry. Just do the math, right? It's 6 times this whole thing. You just realize that it's by the whole thing. So 6 times 3 is 18x minus 6 all over 4, blah, 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 right? Let's go ahead and move this 4 over here. Make it 18x minus 6 equals 3, right? Because we subtracted 4 from both sides. Sorry, this is still over 4 equals 3 because 7 minus 4. And now multiply both sides by 4 to get rid of this fraction. 18x minus 6 equals 12. Move the 6 over. 18x equals 18. Divide by 18, x equals 1. Bring it back over here and check. If we check it, we get 3 times 1 is 3. 3 minus 1 is 2. We have 2/4 plus 2/3 has to equal 7/6. Well, this is 1/2, right? Make this 1/2. And now, if we multiply everything through by 6, you can think about making it a common denominator if you want, but if you multiply everything through by 6, it's going to kill off everything. 6 times 1/2 is 3. 6 times 2/3, well, we did that over here, that's 4. And then 6 times 7/6, that's 7. And those are equal. Okay? Here's how the book would have you do it. It would say the least common multiple is 12. To clear the denominators, multiply everything through by 12. 12 divided by 4 is 3, so this leaves me with a 3. 12 divided by 3, that's 4. That leaves me with a 4. 12 divided by 6, that's 2. That leaves me with a 2. So now I get 3 times this stuff, 4 times this, and 2 times this. 3 times this stuff gives me 9x minus 3. 4 times 2 gives me 8. 2 times 7 equals 14. We combine, right? We combine the negative 3 and the 8 to give us 5. We still have 14 over there. We subtract the 5. We divide by the 9. We get x equals 1, the exact same solution we got. Now let's see how many steps they have. 1, 2, 3, 4, 5, 6, 7 steps. How many steps did we have? 1, 2, 3, 4, 5, 6. Right? We actually did it in one less step. Now, if we broke things out into all the steps they did, then maybe we had 9. Maybe we had 1 or 2 extra steps. But which one do you think is easier? Were you able to look at these and immediately know that 12 was the least common multiple? And then would you be able to do the math right and not make a mistake? So there are a lot of places where you can make errors doing it that way, and that's why I suggest doing it my way. All right, so here's an example with denominators that have x's in them. And in this case, the least common multiple is just the product of the two. So my way and their way is the exact same. But if you just get in the habit of always multiplying by all of the bottoms of the fractions, and then at the end reduce if you have to, I think it's going to be a lot less chance for you to make mistakes. So I would multiply both sides by x plus 4. And x plus 4 would kill this one off. See, they do it all at once, and I don't like that. I think there's a lot of places where it's too overwhelming. Your brain can be thinking too many steps ahead, and you can make silly, stupid mistakes. So instead, multiply both sides by x plus 4. On the left, you get x. On the right, I get 2 times x plus 4. That's a 4 over x. Now, this is multiply both sides by x. X squared equals, I'm going to go ahead and, well, let's not do two things at once. X plus 4, because that killed off the x. Now distribute. 2x plus 8 equals x squared. And now we have a quadratic. And hopefully you know how to solve quadratics. If you don't, we'll kind of cheat and figure out it here, but once we've got rid of fractions, it's always now reevaluate what you have. In this case, we have a squared, a linear, and a constant, so that's a quadratic. Whenever we have a quadratic, we have to set it equal to 0 and solve. So put everything on one side, always leaving the x squared piece positive. Now we solve this by factoring or using the quadratic formula. And in this case, we know it has to be minus 4 and plus 2. Each of these gets set equal to 0, right? Because for two things to multiply to 0, they each have to equal 0. So if this equals 0 or this equals 0, x minus 4 equals 0 means that x equals 4. X plus 2 equals 0 means that x equals negative 2. Those are our two possible solutions. We'd have to plug them both back in and check them, but they actually both end up working. Okay? So that's it for solving these things with fractions. Just remember that the rules are still the same. Get rid of fractions, decimals, grouping objects, blah, 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 blah. When your equations have fractions, multiply by the bottoms. Whether those bottoms are numbers or algebraic expressions, just start doing it to cancel them out or to kill them off. And it's much easier than coming up with least common multiples.